All right, guys, now we're going to do the same kind of analysis but with a parallel circuit. As a reminder, what does this all involve? It involves some of this stuff, which is the rules of a parallel circuit. In other words, you need to understand or memorize how a parallel circuit behaves, and that behavior is captured by equations like the ones in blue. In green right here is the weirdest thing about a parallel circuit, and it has to do with its total resistance. So I wrote the equation in green this time so it stands out, and you've got to remember that this is the most difficult part about a parallel circuit. 1 over the total resistance is equal to this stuff. Another way to think about it is 1 over that total resistance is the sum of all the 1 over resistances, okay? So this green is part of the rules for a parallel circuit. The circuit itself, you can see I drew here. We have 3 resistors again, just like the series circuit. We've got R1, R2, R3, total voltage. We have total current coming out of the battery as always, but now we have current going through each resistor, and we're going to designate them I1, I2, and I3. Here's the table that we're going to fill out as a way to organize everything we know about the circuit. And for review purposes, remember, if I want to fill something out in the rows, I use Ohm's law. And if I want to go up and down the columns, I use the rules of the circuit. Okay? So we're going to start with a similar circuit. I have a 30-volt battery or power source, total of 30 volts, so volt total 30. And I think I had a 10, a 20, and a 30 ohm resistor, so we'll have that again. All right, we want to analyze this circuit. Find everything about the circuit. What do you mean by everything? Fill in the table. Okay, so let's see. Back to Ohm's law, right? And I can't go sideways, I've got empty boxes. Okay, so now it's time to go up and down. Up and down, use the rules of the circuit. The total current is the sum of all the currents. I don't know anything about the current. Nothing there. The voltages, though, are all equal. So I must have 30 volts across all of these guys. Oh, look at that. Hopefully now it starts to pop out. I got Ohm's law going this way, right? So how much current do I have? Ohm's law is equal to V over R. So V divided by 10, I have 3 amps. I've got 1.5 amps, and I have 1 amp. Okay, what about my current? What about my totals down here? All right, this guy, okay, this box down here, we're going to do that 2 ways because I want you to see what it looks like to use this. So let's do the currents first. Anytime you have a whole column almost filled out and just the totals are missing, that's a big clue. So let's see, parallel circuit. Oh, all of the total current is equal to the sum of all the currents. So I add this up, 2.5 plus 3, 5.5 amps. All right. Now, total resistance. You can see I can use Ohm's law. All right. So that's approach number 1. If I have the rows, Ohm's law. But I don't have to, because with a parallel circuit, I've got this rule. And what does it look like to use this rule? Here's what it looks like. So to do the total here, I'm going to apply this rule. I'm going to go 1 over RT is equal to 1 over 10 plus 1 over 20 plus 1 over 30. Okay? And that's going to be some number. I'm just going to put a check mark. You can do that. You take your calculator and you do all this. And you get a number. The most important thing is that what's RT actually equal to? I'm going to call your attention to this part of the screen right here, because this is where we're going to do our talking, okay, right there. If 1 over RT is equal to some decimal number or some number, RT is actually 1 over that number. That's the most important thing to remember here, okay? So what you should do at home, we can figure this out, right, because I can also use Ohm's law here. What I'd like you to do for homework, and make sure, I'm not going to fill this in for you. Go ahead and practice, and we'll check what the answer is in the next class. Also, practice filling out the power column, all right? And if you don't remember how, we went through that in the series circuit. Same thing. We're just going to use the power equations. Okay? So just to sum up, for parallel circuit, same approaches for series in terms of using the table. Use the rules to fill in the VI columns. Last thing, this is the one that you really want to practice, getting that total resistance using this equation. We'll see you in class.